For centuries, humans have imagined space as a place of mystery, danger, and impossible physics. Movies, books, and even classrooms have filled our minds with dramatic ideas about what happens beyond Earth. But as scientists began exploring the universe with telescopes, satellites, and astronauts, many of those ideas started to fall apart. Some myths were exaggerated, some were misunderstood, and some were simply wrong from the very beginning. In this chapter of our journey, we're going to uncover some of the most dramatic myths about space. From what really happens when a human is exposed to the vacuum of space, to the surprising truth about the moon, the sun, and even the asteroid belt. And one of these myths might completely change the way you imagine traveling through the solar system. Myth 5. Humans instantly explode in space. This is one of the most dramatic scenes in science fiction. A character is suddenly exposed to space without a spacesuit. Within seconds, their body swells, bursts, and freezes solid. The image is terrifying, but the truth is very different. If a human were suddenly exposed to the vacuum of space, something strange would happen, but they would not explode. The biggest danger would be the lack of pressure. On Earth, our bodies exist under the pressure of the atmosphere. That pressure keeps gases and fluids inside our bodies stable. In space, where there is almost no pressure, body fluids would begin to boil at normal body temperature. This process is called ebullition. Saliva on your tongue would start to bubble. Moisture in your eyes would begin to vaporize. Your skin would swell slightly as gases expand inside tissues, but surprisingly, your skin is strong enough to prevent your body from exploding. Instead, the biggest threat would be lack of oxygen. Without oxygen, the brain begins to lose consciousness in about 10 to 15 seconds. After that, brain damage would begin within a few minutes. However, if the person were rescued quickly and repressurized, survival might actually be possible. In fact, something similar has already happened. During a vacuum chamber accident at NASA in the 1960s, a technician named Jim LeBlanc was accidentally exposed to near-vacuum conditions. He lost consciousness after about 12 seconds, but after the chamber was repressurized, he recovered. His last memory before fainting was feeling the saliva on his tongue start to boil. It was strange and frightening, but not explosive. Space is still extremely dangerous for the human body, but Hollywood's version is far more dramatic than reality. Myth 6. The sun is yellow. Ask almost anyone to draw the sun, and they will reach for a yellow crayon. From childhood drawings to textbooks, the sun is usually depicted as a bright yellow sphere, but the sun is not actually yellow. In reality, the sun is white. Astronauts who have seen the sun from space report that it shines with a brilliant white light. So why does it appear yellow from Earth? The answer lies in our atmosphere. Earth's atmosphere scatters shorter wavelengths of light, especially blue light. This process is called Rayleigh scattering. It is the same phenomenon that makes the sky appear blue during the day. As sunlight passes through the atmosphere, some colors scatter more than others. By the time sunlight reaches our eyes, the balance of colors shifts slightly toward yellow. That is why the sun often appears yellow from the ground. When the sun is near the horizon, the effect becomes even stronger. Sunlight must pass through a Thicker layer of atmosphere. More blue light scatters away and the sun can appear orange or red during sunrise and sunset. But outside Earth's atmosphere, the sun's light reveals its true color, a brilliant, pure white star. Myth 7. The moon has a dark side. The phrase, the dark side of the moon, is famous in music, movies, and popular culture. It suggests that one half of the moon is permanently hidden in darkness, but that is not how the moon works. The moon does have a far side, which always faces away from Earth. However, that side is not permanently dark. In fact, every part of the moon experiences both day and night. The reason we only see one side of the moon is because of something called tidal locking. Over millions of years, Earth's gravity slowed the moon's rotation until its rotational period matched its orbital period. This means the moon rotates once on its axis in the same time it takes to orbit Earth. As a result, the same hemisphere always faces us. But the far side still receives sunlight during half of its orbit. It has day and night cycles just like the near side. In fact, when astronauts finally photographed the far side of the moon in 1959 using a Soviet spacecraft, scientists were amazed. The far side looked very different. It had far fewer of the dark volcanic plains known as Maria. Instead, it was covered with rugged mountains and craters. Today, we have detailed maps of the entire lunar surface. There is no permanent dark side, only a far side we cannot see from Earth. Myth 8. Space is extremely cold. Everywhere. Another common belief is that space is freezing cold everywhere. Movies often show astronauts instantly turning into frozen statues if their suits fail. But the truth is more complicated. Space does not have a single temperature. Temperature usually describes how fast molecules are moving. But in the vacuum of space, there are very few molecules at all. This means temperature behaves differently than it does on Earth. Objects in space are heated primarily by radiation from stars. For example, in direct sunlight near Earth, temperatures can reach around 120 degrees Celsius. But in the shade, temperatures can drop to minus 100 degrees Celsius or lower. Without an atmosphere to distribute heat, temperatures can swing dramatically depending on sunlight. This is why spacecraft must use special thermal control systems. Satellites and space stations use reflective surfaces, insulation, and radiators to maintain stable temperatures. The International Space Station constantly rotates to balance heating from the sun. So, while space can be extremely cold, it can also be extremely hot. Temperature in space is determined mostly by exposure to radiation, not by surrounding air. Myth 9. The asteroid belt is like a giant field of rocks. Science fiction often portrays the asteroid belt as a chaotic region filled with huge rocks constantly crashing into each other. Spaceships weave between tumbling boulders. Pilots dodge massive collisions every second. It looks thrilling, but the real asteroid belt is nothing like that. The asteroid belt lies between the orbits of Mars and Jupiter. It contains millions of rocky objects, ranging from tiny dust particles to dwarf planets like Ceres, but these objects are spread across an enormous region of space. The average distance between large Asteroids can be hundreds of thousands of kilometers. In other words, spacecraft traveling through the asteroid belt usually encounter nothing at all. Several missions have safely passed through the belt without any difficulty. NASA's Pioneer and Voyager spacecraft crossed it decades ago. Modern missions like Dawn have even orbited asteroids safely. Total mass of the entire asteroid belt is actually less than the mass of Earth's moon. So the dramatic asteroid fields seen in movies are mostly fiction. In reality, the asteroid belt is more like a vast desert with scattered rocks. Myth 10. You should hold your breath in space. Many people believe that if they were suddenly exposed to space, they should hold their breath to keep oxygen inside their lungs. But this would actually make the situation worse. If you hold your breath in a vacuum, the air inside your lungs expands rapidly without external pressure. That expanding gas could rupture delicate lung tissues. This condition is called lung overextension injury. Instead, astronauts are trained that if decompression occurs, they should exhale immediately. Letting air escape prevents dangerous pressure buildup inside the lungs. After exhaling, you would still lose consciousness quickly due to lack of oxygen, but it would reduce the risk of severe internal damage. This is one of many safety procedures astronauts must understand before traveling to space, because in the vacuum of space, even simple decisions can mean the difference between life and death. But the myths we've uncovered so far are only scratching the surface, because coming up next, we will explore some of the strangest misunderstandings about the universe itself, including the myth that the universe had a single explosive beginning, the myth that black holes destroy information forever, and the myth that faster than light travel might be possible. Some of these ideas challenge our understanding of physics. Others push the limits of human imagination, and one discovery might reveal that the universe is far larger and stranger than anyone ever expected. For thousands of years, humans have stared at the night sky and wondered what lies beyond. Ancient civilizations believed the stars were holes in a giant cosmic dome. Others believed the universe was perfect, unchanging, and eternal. Even today, many people think they understand space. But here is the uncomfortable truth. Some of the things you learned about space are completely wrong, not slightly wrong, not outdated, but entirely false. You may believe that space has no gravity. Black holes suck everything like cosmic. Vacuum cleaners. The Great Wall of China is visible from space. Humans would instantly explode in a vacuum. The sun is yellow, and the universe has an edge somewhere. These ideas are repeated in movies, schools, books, and even classrooms. But modern science has revealed something shocking. Most of them are myths. And tonight, we are going to travel across the universe to uncover the truth behind the biggest space myths humanity still believes. Some will surprise you. Some will completely change the way you see the cosmos. And one myth might make you question everything you thought you knew about the universe itself. So before we begin, look up at the night sky. Because the universe above you is far stranger than the one in your imagination. Myth 1. There is no gravity in space. This myth is probably the most common misunderstanding about space. Almost everyone has seen videos of astronauts floating inside spacecraft. Pens drift through the air. Water forms floating spheres. People gently push themselves across the room with a finger dot, and the natural conclusion many people reach is simple. Space has no gravity, but that idea is completely wrong. Gravity exists everywhere. In the universe, it reaches across billions of kilometers. In fact, even far beyond the orbit of Pluto. The sun's gravity is still pulling on objects. So why do astronauts float? The answer lies in one of the most beautiful concepts in physics: orbital motion. The International Space Station orbits Earth at an altitude of about 400 kilometers. That may sound far away, but in cosmic terms it is actually very close. At that distance, Earth's gravity is still about 90% as strong as it is on the ground. So astronauts are not escaping gravity at all. They are actually falling through it. Imagine throwing a ball across a field. The ball moves forward, but gravity pulls it downward until it hits the ground. Now imagine throwing the ball much faster. It would travel farther before hitting the ground. Now imagine throwing it so fast that the Earth curves away beneath it as it falls. Instead of hitting the ground, it keeps missing it. That is exactly what an orbit is. The International Space Station moves around Earth at about 28,000 kilometers per hour. At that speed, it is constantly falling toward Earth, but also moving forward fast enough to keep missing the planet. Astronauts inside the station are falling at the same speed as the spacecraft. Since everything is falling together, there is nothing pushing them against the floor, and that creates the sensation of weightlessness. This phenomenon is known as microgravity. Why? It does not mean gravity is gone. It simply means everything is falling together in the same gravitational field. In fact, astronauts experience the same feeling you might briefly feel on a roller coaster when the track suddenly drops. For a split second, your stomach lifts, your body feels lighter. That moment happens because your body and the roller coaster are accelerating downward together. Astronauts experience that same effect continuously. They are essentially riding a roller coaster around Earth that never stops falling. Myth 2. The Great Wall of China is visible from space for generations. People have repeated a fascinating fact. The Great Wall of China is the only human-made structure visible from space. It sounds impressive. After all, the wall stretches for more than 21,000 kilometers across China. Surely something that massive must be visible from orbit. But when astronauts finally reached space, they discovered something surprising. The Great Wall is actually very difficult to see from space. There are several reasons. First, the wall is relatively narrow. Most sections are only 6 to 7 meters wide. From hundreds of kilometers above Earth, that width becomes incredibly small. Second, the wall's color blends with the surrounding landscape. It is made from stone, earth, and bricks that match the terrain around it. From orbit, it does not stand out strongly against the environment. Third, Earth's atmosphere creates haze, clouds, and light scattering that further obscure small details. Because of these factors, astronauts report that it is rarely visible to the naked eye. Ironically, many other human structures are easier to see. Large cities glow brightly at night. Airports, highways, and massive bridges can sometimes be spotted more easily. The myth about the Great wall actually started long before space travel existed. In the 18th century, writers speculated that such a large structure might be visible from space. But at that time, nobody had ever left Earth. It was simply an assumption. Once astronauts finally saw the planet from orbit, they realized the truth. The Great Wall is extraordinary, but it is not the only human creation visible from space, and often it is not visible at all. Myth 3. Black holes suck everything like giant cosmic vacuums. Few objects in the universe capture human imagination like black holes. Movies portray them as enormous monsters that devour everything nearby. Stars, planets, and entire galaxies are shown being sucked into swirling cosmic maelstroms. But the reality is far more subtle. Black holes do not suck objects in like vacuum cleaners. They obey the same gravitational laws as any other object. The key difference is simply density. A black hole forms when a massive star collapses under its own gravity. The core compresses into an incredibly tiny region of space. So tiny that gravity becomes overwhelming. The boundary around a black hole is called the event horizon. Once something crosses that boundary, escape becomes impossible. But here is something surprising. If the sun were suddenly replaced by a black hole with the same mass, Earth would not be sucked in. Our planet would continue orbiting exactly as it does now. The only difference would be that the sky would become dark. The sun's light and heat would disappear. Temperatures would drop dramatically. Life on Earth would quickly freeze, but our orbit would remain stable. Why? Because gravity depends on mass and distance, not the type of object. A black hole with the same mass as the sun would exert the same gravitational pull. Black holes only become dangerous when objects get very close. Near the event horizon, gravitational forces become extreme. Stars that wander too close can be torn apart in a process called spaghetti. Fication. Gas and dust falling toward the black hole form a glowing disk called an accretion disk. Friction inside this disk heats material to millions of degrees, producing powerful radiation. But far away, black holes behave just like any other massive object in space. They are not cosmic vacuum cleaners. They are simply regions where gravity has become so intense that nothing, not even light, can escape. Myth 4. Space is completely silent. In science fiction movies, space battles are often filled with explosions and roaring engines. But in reality, space is silent, or at least silent to human ears. Sound requires a medium to travel through. On Earth, sound moves through air as vibrating pressure waves. In water, sound travels through liquid molecules. But space is mostly a vacuum. There are very few particles for sound waves to move through. Without a medium, sound cannot travel. So if two spacecraft collided nearby in open space, you would see the explosion, but you would hear nothing. However, this does not mean the universe is truly silent. Space is filled with electromagnetic waves, magnetic vibrations, and plasma oscillations. Scientists can detect these signals using spacecraft instruments. By converting them into audio frequencies, we can actually listen to the universe. Planets like Jupiter produce powerful radio emissions. Saturn's magnetic field creates eerie electrical sounds. Even black holes generate signals that can be transformed into haunting cosmic tones. When scientists convert these signals into sound, the universe becomes surprisingly musical. Strange whistles, deep rumbles, pulsing rhythms. It is as if space itself is quietly humming a cosmic symphony. We just need the right instruments to hear it. But the myths we've explored so far are only the beginning, because coming up next, we're going to bust the myth about what really happens if a human is exposed to the vacuum of space. And the truth is very different from what movies show. No instant explosions. No dramatic freezing, but something far more unsettling. And later, we'll reveal the myth about whether the universe actually has an edge, a mystery that has puzzled scientists for decades. By now, we've uncovered some incredible truths. The Big Bang was not an explosion. The universe does not have a center. Light does not travel instantly. And time itself can slow down near massive objects. But the deeper scientists look into space, the stranger the universe becomes. Because when astronomers started measuring galaxies and cosmic motion, they discovered something shocking. Most of the universe is invisible, not hidden behind clouds. Not too far away to see. But completely undetectable with ordinary light. To understand this mystery, we must first confront another powerful myth about the cosmos. Myth 16. Black holes destroy everything forever. Black holes are often described as cosmic traps. Once something falls inside, it is gone forever, destroyed completely, erased from the universe. At least, that's what scientists believed for many years. But in the 1970s, physicist Stephen Hawking discovered something surprising. Black holes are not completely black. They actually emit a tiny amount of radiation. This radiation is now known as Hawking radiation. According to quantum physics, empty space is never truly empty. Tiny particle pairs constantly appear and disappear in the vacuum. Near a black hole's event horizon, something unusual can happen. One particle may fall into the black hole while the other escapes. To distant observers, it appears as if the black hole is slowly losing energy over extremely long periods of time. This process could cause black holes to evaporate, but this discovery created a huge problem in physics. If black holes evaporate completely, what happens to the information contained in everything they swallowed? According to the laws of quantum mechanics, information cannot be destroyed. This puzzle became known as the black hole information paradox. For decades, scientists debated this mystery. Some believed information was truly lost forever. Others proposed that information might somehow be encoded on the surface of the event horizon. Modern theories suggest that information may survive in extremely subtle ways, but the final answer is still unknown. What we do know is this: black holes may not destroy everything after all. Instead, they might be cosmic archives hiding information in ways we do not yet understand. Myth 17. Dark matter is just invisible dust. In the early 20th century, astronomers believed they understood galaxies fairly well. Stars orbit the center of a galaxy due to gravity, just like planets orbit the sun. But when scientists began measuring how fast stars move inside galaxies, something didn't make sense. Stars at the edges of galaxies were moving far too fast. According to the visible mass of the galaxy, those stars should have flown away into space. But they didn't. Something unseen was holding galaxies together. This mysterious substance became known as dark matter. Dark matter does not emit light. It does not reflect light, and it does not interact strongly with ordinary matter. But it has gravity. And that gravity shapes the structure of the universe. Today, scientists estimate that about 85% of all matter in the universe is dark matter. That means everything we can see, stars, planets, gas clouds, and galaxies, makes up only a small fraction of reality. Dark matter forms huge invisible halos around galaxies. It acts like a gravitational scaffold that keeps galaxies stable. Without dark matter, galaxies might never have formed at all. Despite decades of research, scientists still do not know exactly what dark matter is. Some theories suggest it may consist of unknown particles. Others propose entirely new physics beyond the standard model. But one thing is clear: the universe we see is only a small part of the total cosmic structure. Most of reality remains hidden. Myth 18: galaxies are randomly scattered when we look up at the night sky. Stars appear scattered randomly across space. For many years, scientists assumed galaxies were distributed randomly as well. But when astronomers began mapping millions of galaxies across vast distances, they discovered something extraordinary. Galaxies form enormous cosmic structures. Instead of being random, they arrange themselves in a pattern called the cosmic web. This structure looks like a giant three-dimensional network. Long filaments of galaxies stretch across hundreds of millions of light years. These filaments intersect at dense clusters containing thousands of galaxies. Between the filaments lie enormous empty regions called cosmic voids. Some of these voids are hundreds of millions of light years wide from a distance. The cosmic web looks surprisingly similar to the structure of neurons in the human brain, or the delicate strands of a spider's web. Dark matter is believed to play a crucial role in forming this structure. Its gravitational pull guides ordinary matter into these vast filaments. Over billions of years, galaxies form along these invisible pathways. So the universe is not chaotic or random. It has a beautiful large-scale architecture stretching across unimaginable distances. Myth 19: the Milky Way is a typical galaxy, our home galaxy. The Milky Way contains hundreds of billions of stars. For a long time, astronomers believed it was an ordinary spiral galaxy among billions of others. But recent observations suggest our galaxy may actually be somewhat unusual. First, the Milky Way is relatively quiet compared to many galaxies. Some galaxies experience intense star formation or violent collisions. Galaxy has been comparatively stable for billions of years. This stability may have helped life evolve on Earth. Second, the Milky Way contains a surprisingly large number of satellite galaxies. These smaller galaxies orbit our own, forming a complex gravitational system. Finally, our galaxy lies inside a larger structure known as the local group. This group includes more than 50 galaxies bound together by gravity. The largest members are the Milky Way and the Andromeda galaxy. And here's something fascinating. In about 4 billion years, the Milky Way and Andromeda will collide. But don't worry, even though billions of stars are involved, direct stellar collisions will be extremely rare because of the enormous distances between stars. Instead, the two galaxies will slowly merge into a new galaxy, sometimes called Milkomeda. Cosmic events unfold on timescales far beyond human history, but they remind us that the universe is constantly evolving. Myth 20, space is mostly empty. Nothingness. It's easy to imagine space as a vast empty void, just endless darkness between stars and galaxies. But space is not completely empty. Even the emptiest regions contain particles, radiation and energy fields. Interstellar. Space contains clouds of gas and dust. These clouds can eventually collapse under gravity to form new stars. Intergalactic space contains extremely thin plasma and cosmic rays. And on the smallest scales, quantum physics tells us something even stranger. Empty space is filled with quantum fluctuations. Tiny particle pairs constantly appear and disappear. These fluctuations may seem insignificant, but some physicists believe they played a crucial role in the birth of the universe itself. So even the vacuum of space is not truly nothing. It is a dynamic environment filled with subtle activity. But the deeper we explore the universe, the more mysterious it becomes, because scientists have discovered something even stranger than dark matter. Mysterious force that seems to be pushing the universe apart, faster and faster. This force is called dark energy, and it may control the ultimate fate of the cosmos. Will the universe expand forever? Will it tear itself apart? Or could it eventually collapse back into another cosmic beginning? In the next chapter, we will uncover the myths surrounding dark energy, cosmic expansion, and the possible future of the universe. And the answers might change the way you think about the destiny of everything that exists. By now, we've already uncovered some surprising truths about space. Astronauts don't float because gravity disappears. The Great Wall of China is rarely visible from orbit. The sun isn't yellow, and space isn't always cold. But those myths are only the beginning, because the biggest misunderstandings about space aren't about astronauts or planets. They are about the universe itself. How it began, how it works, and how far its mysteries truly go. For decades, scientists have studied the cosmos using powerful telescopes, satellites, and mathematical theories. And again, they've discovered something unexpected. Reality is often stranger than the myths we created to explain it. In this chapter, we're going to explore some of the most fascinating myths about the structure of the universe itself, from the misunderstood story of the Big Bang to the surprising truth about the speed of light and the mind-bending possibility that time itself behaves differently across the cosmos. Myth 11. The Big Bang was an explosion in space. When most people hear the phrase Big Bang, they imagine something dramatic. A giant explosion in empty space, a burst of matter and energy blasting outward in every direction. But this image is misleading. The Big Bang was not an explosion inside space. Instead, It was the expansion of space itself. About 13.8 billion years ago, the universe existed in an incredibly hot, dense state. Everything we know today, every galaxy, every star, every atom was compressed into an extremely small region. Then something extraordinary happened. Space itself began to expand. Not matter flying outward through space. But space stretching everywhere simultaneously. To understand this, imagine dots drawn on the surface of a balloon. When the balloon inflates, the dots move farther apart, but the dots are not moving across the balloon. The balloon itself is expanding. That's similar to what happened to the universe. Galaxies are not racing outward from a central explosion point. Instead, the fabric of space between them is stretching. This explains one of the most important discoveries in modern astronomy. When scientists observe distant galaxies, they see their light shifted toward the red end of the spectrum. This phenomenon is called redshifT. It happens because light waves stretch as the universe expands. The farther away a galaxy is, the faster it appears to be moving away from us. This observation was first discovered in the 1920s by astronomer Edwin Hubble. And it changed our understanding of the universe forever. The Big Bang was not an explosion. It was the birth of space itself expanding outward in every direction at once. Myth 12. The universe has a center. If the universe expanded from the Big Bang, it seems logical that there must be a center somewhere. After all, explosions usually have a starting point. But in cosmology, things are more complicated. According to current theories, the universe does not have a center. Remember the balloon example again. Imagine tiny creatures living on the surface of the balloon. As the balloon inflates, every creature would see all other points moving away, but none of them would be able to identify a central point on the surface. From their perspective, expansion is happening everywhere. Our universe behaves in a similar way. Space is expanding uniformly in all directions. From Earth, distant galaxies appear to move away from us. But observers in another galaxy would see the exact same pattern. From their perspective, we would appear to be moving away from them. In other words, every location in the universe appears to be the center of expansion. This strange idea means the universe does not expand outward into empty space. Instead, space itself is growing everywhere simultaneously. There is no special location where the not expansion began, and there may not be an edge either. Myth 13. Light travels instantly. Light moves incredibly fast. In fact, it is the fastest thing known in the universe. Its speed is about 299,792 kilometers per second. That's fast enough to circle Earth more than 7 times in a single second. Because of this speed, many people assume light travels instantly. But even light takes time to cross the vast distances of space. Sunlight takes about 8 minutes to reach Earth. When you look at the sun, you are actually seeing it as it was 8 minutes ago. If the sun suddenly disappeared, hypothetically speaking, we wouldn't know about it for 8 minutes. The distances between stars are even more enormous. The nearest star system, Alpha Centauri, is about 4.37 light years away. That means its light takes over 4 years to reach us. When astronomers observe distant galaxies, the delays become even more dramatic. Some galaxies we see today are so far away that their light began traveling toward Earth billions of years ago. In other words, when we observe deep space, we are actually looking into the ancient past of the universe. Telescopes are not just tools for seeing distant objects, they are time machines that allow us to observe cosmic history. Myth 14. Time is the same everywhere on Earth. Time seems constant. A second passes the same way everywhere. Clocks tick at the same rate whether you are in a city, on a mountain, or flying in an airplane. But according to Einstein's theory of relativity, time is not universal. It can actually slow down or speed up depending on gravity and motion. Near massive objects like planets, stars, or black holes, gravity warps space and time. The stronger the gravity, the slower time moves relative to distant observers. This phenomenon is called gravitational time dilation. For example, clocks on satellites orbiting Earth tick slightly faster than clocks on the ground because gravity is weaker at higher altitudes. Scientists must correct for this difference to keep GPS systems accurate. Without these corrections, GPS navigation would drift by several kilometers each day. Near extreme objects like black holes, time distortion becomes even more dramatic. If someone could safely orbit close to a black hole, their clock might run much slower than clocks on Earth. Hours for them could equal years for distant observers. This strange effect was famously illustrated in the movie Interstellar, but the science behind it is real. Time is not the same everywhere in the universe. It is shaped by gravity and motion. And in extreme environments, it can behave in ways that seem almost impossible. Myth 15. Wormholes allow easy travel. Across the universe, science fiction often shows spacecraft jumping instantly across the galaxy using wormholes. A wormhole is a hypothetical shortcut connecting two distant points in space and time. In theory, it could allow travelers to move enormous distances almost instantly. The idea comes from solutions to Einstein's equations of general relativity. These equations describe how gravity shapes the fabric of space and time. Some mathematical solutions suggest the possibility of tunnels linking distant regions of space-time. But there is a problem. Most theoretical wormholes would collapse instantly. To keep a wormhole open, scientists believe it would require something called exotic matter. This mysterious substance would need to have negative energy density, something that has never been observed in usable quantities. So while wormholes are fascinating theoretical ideas, there is currently no evidence that stable wormholes exist in reality. Traveling across the galaxy in seconds remains firmly in the realm of science fiction. For now, the vast distances between stars remain one of the greatest barriers to human exploration. But the myths we've explored so far are just the beginning of the universe's mysteries, because coming up next, we will uncover some of the most shocking misconceptions about black holes and cosmic structures, including the myth that black holes destroy everything forever, the myth that galaxies are evenly spread across space, and the mysterious truth about dark matter, the invisible substance that may make up most of the universe. Some scientists believe dark matter could hold the cosmic web of galaxies together. Others think it might reveal entirely new physics. And if they're right, the universe could be far stranger than we ever imagined.